In the last lesson, we learned about two major characteristics of linear graphs, the x and y intercepts. There's another characteristic of the graph of linear functions that we're going to look at today, though. That's called the slope. The slope of a line is a measure of its direction, as in does it tend to go up or down, and its steepness, as in how quickly does it go up or down. Now, slope is calculated as the ratio of the vertical distance to the horizontal distance between 2 points on the line. So, if you pick 2 points on a line, work out how far across you went, either left or right, and work out how far vertical you went, either up or down, and then it's the ratio of those two is the slope. Now, when we say distance, what we really mean is a change in position. So this is really the change in the vertical position and a change in the horizontal position. But on a graph, those positions have actual meanings. Vertical position represents the output of the function, and horizontal position represents the input of the function. So really, this is the change in the output and the change in the input. Well, hang on, we already have something that is the ratio of the change in the output to the change in the input. So it turns out that the slope of a graph of a linear function is identical to the function's rate of change. So if we want a formula for slope, it's a formula we're already familiar with. M is equal to delta y over delta x. But this time we can think of delta y as being vertical distance and delta x as being horizontal distance. Now don't forget, we can write this in another form as well. We can say that the vertical distance is equal to the slope multiplied by the horizontal distance. Remember, the previous way we had of describing it was that the change in the output is equal to the rate of change times the change in the input. Now we're just using the language of graphs and lines to describe it, but it has the exact same meaning. Let's look at some examples of lines and see how we can kind of generalize this. So if we have a line that's sloping up like this, now you might argue, well, there's an arrow on both ends. How do we know which way is up? Well, we always take our lines going from left to right, okay, because that's what represents an increasing input. So for this, our input is increasing. At the same time, our output is also increasing. So this is up, which means our rate of change, or our slope, is greater than 0, or it's positive. If it's going the other way, as our input is increasing, as our horizontal position increases, our vertical position is going down, it's decreasing. So we would say that this is sloping down, and we would say that our slope, or our rate of change, is less than 0. It's negative. If we have a line that's perfectly horizontal, let's actually write that, it is horizontal, then there is no change in the vertical position at all. There's no vertical distance. So the slope of this line is 0. And finally, and we won't actually see much of that in this class, and the reason for that is you can't actually get this from a function, but there are related topics in which you can have a vertical slope. In this case, we say that m is undefined, because that would involve no horizontal change at all, which means in our ratio, we'd be dividing by 0, which doesn't make any numerical sense. So we say that m as a number is undefined. So these are the 4 main types of slopes that we can have, but it's these first 2 that we will mostly focus on for linear functions. So we have a graph here, and we are asked to calculate the slope of the line. Now, notice that our line passes over a grid. Some of the points on the line are at grid intersections, but some are not. So let's focus on the ones that are at grid intersections, because they're going to be easy to work with. So we have a point here, and there's one here, and there's one here, and there's one here, and there's one here. So we can see that to go from this point here to this point here, we have a horizontal change that's 3 units across, and then a vertical change that's 1 unit up. In fact, we can keep doing that. We go 3 units across to 1 unit up, 3 units across to 1 unit up, 3 units across to 1 unit up. So the line goes 1 unit up for every 3 units right. So delta y, our vertical distance, is 1, and delta x, our horizontal distance, is 3. Now both of these are positive, because remember, to the right is our positive direction for x, and up is our positive direction for y. So the slope is delta y divided by delta x, which is 1 over 3, or 1/3. And this doesn't simplify, so we'll just leave it as that. So we haven't actually worked out a rule for this graph yet, but we have worked out the slope, which, remember, is the same as the rate of change. Okay. For the next question, it asks us to describe the direction of a line with slope 5/2, or 5 over 2, and describe the direction of a line with slope -2/3. Well, what these really mean is, for this line, the line will go, or goes, 5 units up for every 2 units to the right. And I'm going to switch colour here, because we're going to have to draw these lines in a moment, and I want to be able to tell which one is which. So this second one, the line goes... Now notice we have a negative slope here. So that really means we go 2 units down for every 3 units right. Because remember, our fractions, which represent our slope, really give us our delta y and our delta x. So if we're going to draw these, let's draw them on the graph. Now, it doesn't really matter where we start our line because it doesn't say anything about the location of drawing them. It just says draw an example of lines with these slopes. So I'm going to start for my first one, my slope of 5/2. I'm going to start here. So from this point, if I go 2 units across, I need to go 1, 2, 3, 4, 5 units up. Then I go 2 units across and go 1, 2, 3, 4, 5. Let's double check I've got that. And then 2 units across. 1, 2, 3, 4, 5. And then I can draw my line through those points. I'm going to label that as m equals 5/2. Let's draw a line with slope -2/3. So I'm going to pick a point. Notice this will be going down. So I'm going to start on the upper part of my graph here, and I'm going to start on the side because I know that I'm going to go more across than I'll go down because I'm doing only 2 units down for every 3 units right. So 1, 2, 3 units would be there, and then 2 units down would be there. 1, 2, 3 units to the right, and then 1, 2 units. Bit obscured by the other line, but that'll be there. 1, 2, 3 units right, 2 units down. 1, 2, 3 units right, 2 units down. 3 units right takes me off the grid, so I'll stop there. And there we go. There's our line. Now notice the second one that I've drawn, not only does it go down because we have negative slope, but it's kind of flatter than the other line. It's not as steep. And that's because, well, the value that represents it, aside from the whole being negative part of it, it's a smaller fraction. 2/3 is smaller than 5/2. So 5/2 ends up being quite steep. Well, 2/3 is, well, not completely flat. It's a lot flatter. Not as steep as that other line. Let's continue looking at some further examples. So this asks us to plot the line which passes through the point 5, 6 with slope 2. Now we know what it means for slope 2. That means our ratio is, our ratio of change in y and change in x is 2. Or another way to say that is that delta y is 2 times delta x. So however many units I go across, I have to go twice as many units vertical. That's positive 2, so I'll be going up. Well, that doesn't help starting from this point. That only helps us getting there, so we're going to have to work backwards to get the others. So if I go to the left 1 unit, I'll go down 2 units, which will take us there. Then 1 and 2. 1 and 2. So notice all I'm saying is that whatever change I make in the x direction, I have to do double that change in the y direction. And then that will take me off the grid. Remember, that's what slope really means. Slope of 2 means that any change in x, I have to double it to get my change in y. Okay. So, next question asks, what are the intercepts of this line? Well, we can just read them off the graph now. We have our x-intercept at 2. So, the x-intercept is 2, 0. And the y-intercept, the y-intercept always has x equals 0, and the y-coordinate is -4. Now, next it says that the point 9k is also on the line. So k is a constant here. It's a number. We're just not being told what it is yet. In fact, that's what they want us to find. What is the number that goes here that means this point is on this line? Now, that would be easy enough if our coordinate grid went up to 9. Unfortunately, it doesn't. So we can't actually just look on the graph and tell what the coordinates are. But I think we can figure this out. If we make ourselves a table, so using x and y, we know that our starting point was 5, 6. And from there, we want to get to 9 something. Well, we don't know what this number is yet, but we can work out what the change in x needs to be. To go from 5 to 9, we have to add 4. Now, before, we said that the change in y has to be 2 times the change in x. Well, the only way that works is if this change in y is 8. And if we did that, that means we would have the coordinate 14. So this line passes through the point 9, 14 because our change in y is 2 times the change in x, which is 2 times 4, which is 8, which means that k must equal 14. One last example. So this asks, what is the slope of the graph y equals -1/3 of x plus 2? And we've already stated that the rate of change of a function is the same as the slope of the graph. And the rate of change of a function is the number we multiply x by. It's m in y equals mx plus b. So, let's actually work that out. Well, let's just write it down, really. M is -1/3. Now, next thing it asks us is to find the y-intercept. So, remember that the y-intercept occurs when x is equal to 0. So that means that y is equal to -1/3 of 0 plus 2. Now, -1/3 of 0 is 0. So this is really just 0 plus 2, which equals 2. So the y-intercept has the coordinates 0, 2. That would be the point right here. Next, it wants us to plot the graph of the function using the slope that we've calculated. So we know that the slope is -1/3. What that means is we'll be going 1 unit down because it's negative. For every 3 units, we go to the right. So from our starting point, which we have on this intercept right here, we can go 1, 2, 3 units right. We'll have to go 1 unit down. 3 to the right, 1 unit down. 3 to the right, 1 unit down. Now I want to go back the other way to get one more point. So if I go 3 units left, because I'm going the opposite, I'll need to go 1 unit up. And if we've done this correctly, we have a straight line, which we can rule. Put arrows on either end to represent that this keeps going in both directions. And since we've made a graph, we may as well label it with the function it represents. So y is equal to -1/3 times x plus 2.